All right, today we are diving into a really out there idea called the symbols framework. And trust me, it's a completely different way of looking at pretty much everything: reality, consciousness, how we even know what we know. The basic idea: the universe isn't just some box full of stuff, it's an active, unfolding story. Let's get into it.
So, think about all the biggest head scratchers in science, the stuff that keeps physicists up at night. Quantum mechanics, the mystery of consciousness. What if these aren't just really, really hard problems? What if they're actually clues, telling us that our fundamental rulebook for how reality works is just wrong?
So, what are we talking about here? What are these so called unsolvable puzzles? Well, these are the paradoxes that have been pushing science to its absolute limits for decades, making it feel like we're missing a huge piece of the puzzle. Okay, first up, the classic, the quantum measurement problem. You've probably heard of the double slit experiment. Particles, like electrons, act like this weird wave of every possibility all at once, right up until you try to look at them. The moment you measure them, bam, reality seems to just pick a state. And for 100 years, scientists have been asking, why? What is an observer anyway, and what's this crazy power they seem to have? And if you thought that was weird, the Wigner's friend thought experiment takes it a step further. Imagine a scientist, the friend, is inside a sealed lab and measures a particle. Okay, for her, the result is real. It's a fact. But for her colleague Wigner, standing outside the lab, the friend and the particle are both still in this fuzzy quantum superposition. So, when did reality actually happen? Whose observation is the one that counts? I mean, this whole thing throws the idea of a single objective reality right out the window. And then there's the big one: consciousness. This is the hard problem, right? We can watch how a brain fires neurons and processes information, and it looks a lot like what a computer does. But why is it that a brain has this internal subjective experience, the actual feeling of seeing the color red or the taste of coffee, while a supercomputer, no matter how powerful it gets, is really just crunching numbers? What makes one a genuine agent and the other just a very complicated machine? Puzzles like these are screaming for a new perspective. So this is where the symbols framework comes in. It basically throws out the old rulebook and gives us a completely new one for how reality actually works, from the tiniest particles all the way up to us. At the heart of it all is this thing called the symboliad. Now, don't think of it like a blueprint where every possible future is already mapped out. It's way more dynamic. Think of it more like a living source code for reality. It's this set of flexible rules or constraints that guide how things can even come into being. It doesn't just hold all the possibilities, it actually shapes how they can form. So what about that weird quantum collapse, where an observer makes things real? Well, the framework calls this externsive collapse. And this is absolutely crucial: it has nothing to do with a conscious person looking at it. Instead, it's an objective event. It happens when a system's potential sort of runs out of road. It hits its own structural limits, can't stay in that fuzzy state of possibility anymore, and is forced to stabilize into one definite outcome. And the result of that collapse? That's called a symbol 2.0. This is a solid, concrete piece of reality. A particle's position, a conscious thought, a brand new idea. But here's the cool part: it's not just a snapshot in time. It's more like a fossil. It carries the entire history of the process that created it. It's an enacted reality, and its own past is baked right into it. This slide here just lays it all out perfectly. It's this continuous cycle called the generative loop. You see, you start with generativity, just pure open-ended potential. Then the constraints from the symbolic kick in and start to limit the possible paths. This carves out a specific pathway, and eventually that potential just runs out of steam in extrinsic closure. That triggers the collapse, and boom, a new symbol 2.0, a new piece of reality is born. And the framework says this loop is happening everywhere, all the time, at every single scale. So, how does this new rulebook tackle consciousness? Well, this is where it gets really interesting, because the framework draws a very sharp, very clear line between a simple machine and a real conscious agent. The whole idea boils down to something the source material calls rule opacity. And this quote here just nails it. For any system to be considered a conscious agent, you can't just figure out its rules by looking at it from the outside. You have to get in there and participate. You have to play the game to figure out how it works. And this is a huge break from how we usually think about it, right? The common idea is that consciousness just sort of happens when a system gets complicated enough. You add enough processing power and eventually the lights turn on. But the symbols framework says, nope, that's not it at all. The difference is fundamental. If you can read the rulebook from the outside, it's a machine. If you actually have to play the game to learn the rules, then it's an agent. Period.
Now, this is where we can really see the difference. Here we're stacking it up against a really popular theory called integrated information theory, or IIT. Just look at that first row, the nature of rules. For IIT, the rules are transparent. You can figure them out from the outside. But for the symbols framework, they have to be enacted. And that single difference is why IIT can lead to some really bizarre ideas, like a massive grid of light switches that are all turned off being somehow conscious. The symbols framework says, no way. You have to actually play the game. You need that rule opacity.
And this isn't just some philosophical hand-waving. It's actually grounded in some pretty heavy mathematics. The easiest way to think about it is this. A computer is like a machine that comes with a complete instruction manual. You can read the whole thing and know exactly what it's going to do. That's what they call a type 1 system. But a real agent, that's a type 3 system. And in that system, there is no manual. The rules only exist and are created in the very act of playing the game. You literally can't write them down because they aren't separate from the process itself. Okay, so if any of this is right, the implications are just huge. It's not just about giving us new answers to old problems. It completely changes how we think about science, discovery, and what it even means to know something.
Let's take a super hard problem in computer science, like P versus NP. The framework suggests that maybe the reason we can't solve it isn't because it's too difficult, but because we're asking the question in the wrong way, with the wrong set of tools. We're trapped in what's called a symboliad cone, a whole reality with its own set of rules that literally cannot contain the solution.
So how do you solve it? Through a process called extension. This is like a sudden, nonlinear leap of insight. It's a collapse that shifts the entire problem into a brand new cone, a new reality where an answer all of a sudden becomes possible. But here is the absolutely wild part. The solution doesn't just answer the question you asked. It actually reaches back in time and changes the meaning of the question itself. I mean, this quote from the source material just says it all. Under the evidence of the proof, the past changes. Think about Einstein's theory of relativity. It didn't just give us a new formula for gravity. It completely rewrote our entire understanding of space and time and the entire history of physics that came before it. The proof literally changed the past. So, let's just boil this all down. What are the big things to take away here? First, reality isn't some fixed, static thing. It's a creative, generative process that's constantly unfolding. Second, real agency, real consciousness, isn't about how complicated you are. It's about being in a game where you have to play to learn the rules. And finally, the biggest breakthroughs in knowledge don't just give us new answers. They completely change the questions we were asking in the first place. So this framework leaves us with one last, really provocative thought. If a discovery can actually change the history of the problem it solves, then it really makes you wonder, are the biggest, most impossible questions we face today just waiting for a solution that will show us we've been asking them all wrong? It's a challenge to think not just about the answers we want, but about the very questions we're currently allowed to ask.